In this video, we're going to do an example of the extreme value theorem. Our function is p of t equals sine t plus cosine t, and our interval is negative pi over 2 to pi over 2. We have a continuous function and a closed interval, so the extreme value theorem guarantees us an absolute or global max and min. So the first thing I'm going to do is find critical points, by taking the derivative. This is not a bad derivative. Derivative of sine is cosine of t. Derivative of cosine is negative sine of t. Now we're going to set that equal to 0. So we are looking for values for cosine of t equals sine of t. Well, one that comes to mind right away is pi over 4. Now there's an infinite amount of places where these two are equal, but we're only concerned with places in between negative pi over 2 and pi over 2. So if you think of trig, that's only on this side of the plane. So pi over 4 is one of them. The other one's going to be negative pi over 4. So those are the only two critical values we're concerned with. Now what we're going to do is evaluate our function at our endpoints and our critical points and see what comes out to be smallest and what comes out to be largest. And that'll be our final answers. So p of negative pi over 2. Remember, this is going into the original function. Sine of negative pi over 2 is negative 1. Cosine of negative pi over 2 is 0. So it's negative 1. P of pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. So that's 1. Pi over 4. Sine of pi over 4 is read 2 over 2. Cosine of pi over 4 is also read 2 over 2. So basically we get 2 rad 2 over 2 or rad 2. Finally, calculating p of negative pi over 4. Sine of negative pi over 4, it's going to put us down here, that's negative rad 2 over 2. Cosine negative pi over 4 is going to be rad 2 over 2, so that's equal to 0. So our biggest value here is rad 2, it's about 1.4, so that's going to be our absolute or our global max. Our smallest value here is at negative 1, so that's going to be our absolute or our global min by the extreme value theorem.